All right, so I'm going to do the best I can to do an introduction to binary numbers for you. And hopefully this will help get caught up on some of the work. We just finished the binary assignment today, so you have time to still complete this. So when we talk about binary, we're talking about a number system. So we have different number systems that we're familiar with. So the first is the decimal number system that we're probably most familiar with. So our decimal system is considered, our decimal system is called base 10. And that's because we have 10 different characters, 10 different numbers that we use to represent the numbers that we're familiar with. So that's 0 through 9. So 0, any number that we're familiar with, we could create with that number system, so 0 through 9. That's what it means. Now, computers use something called binary. Binary is a base 2 number system, which means that it only has 2 possible options for numbers. It's a 0 and a 1. Binary is the base level language for all computers. All computers speak in binary. So at some point, we have to be able to convert their number system, the computer's number system, from binary into decimal, or from decimal into binary. And we have a special way of doing that. We have something called a Flippy-Do, which is a paper device that you should have already seen linked in the assignment. There should be another link for you in Canvas, or even I'll link one directly in the email that I'm sending you in order to do this. Now we have to be able to convert from one to the other, and I'm going to show how that happens right now. So we have this chart that's going to kind of help us along the way. So because this is a base 2 number system, it increases exponentially. Oops, I have an error already there. Let me fix that really quick. For how we're going to calculate our numbers. So 2 to the 0 power is going to be 1. That's going to be 2. 2 to the second power is 4. 2 to the fourth power is 8. And this doubles every time. Am I missing one? 1, 2, 3, 4, 5, 6, 7. I am missing one. I'm going to draw this last one on the end. We're supposed to have 8. Somehow I didn't have that last one. So 2 to the 8th. This is 128. Now these are all natively 0 right here. And here's the way this works. So if we want to represent the number 1 in binary, we would simply get rid of this 0 and put 1. So that means that this would be 0, 0, 0, 1. Now if we want to write 3, we would have to do a simple just addition problem. So now this becomes 0011 is how you write the decimal number 3 in binary. So everything is additive. I'll give you another example. What if we want to write the number 25? I think that would be a good one to practice with. The way you approach this is you find the largest value that you can start with. So 32 is too big, so that means we're left with 16. So we're going to say 16. And what would we have to add to 16 to make it 25? Well, 16 plus 8. You always want to use the largest numbers you can. 16 plus 8 is 24. And we need one more for 25. So that means that we need this last placeholder here. So that means 25 in binary is 1, 1, 0, 0, 1. And so that's how you're calculating it. That may not help you answer all the questions on the assignment, but it should get you through most of them. Now, one more thing I want to comment on is that every one of these placeholders right here is called a bit. So a bit is the smallest unit of measurement of memory in a computer. So that means that this entire thing is 8 bits. Because that'll come up in some later questions. So in order to write 25 in binary, we needed 1, 2, 3, 4, 5 bits in order to make that happen. So that gets you through most of the assignment. That's pretty good. I could walk you through some of the other questions later on if you're confused about some of the questions after the chart that you have to fill out. But that should be enough to kind of get you started. Feel free to send me any questions you have or any other further explanation you might need. All right, that's it for right now.